everybody. Uh, I'm Dr. Ahmed Elhag. I'm working in King Khalid University, College of Engineering, Department of Civil Engineering. I thanks all the organized conference of water resources. Bismillahirrahmanirrahim. Hello, everybody. Uh, I'm Dr. Ahmed Elhag. I'm working in King Khalid University, College of Engineering, Department of Civil Engineering. I thanks all the organized conference of water resources and arid environment. The title of my presentation is New Methods for Estimating the Well Efficiency. The outline of the presentation is a compare between all methods of step drawdown test and the new methods for me, because the old methods included some observed such as the difference between water level in aquifer and water level inside the well. In this slide, they are different point between this point or in this point, the water level in the aquifer or laminar flow, but in this point, refer to non-laminar flow inside the well. This difference between 2 points led to well efficiency less than 100%. Next slide. Discuss the old methods and step bumping test for different yield. For the old methods, compute the total well loss. There are different type of losses, including linear well loss and non-linear loss. Total well loss equal linear well loss B2Q plus turbulent well loss CQ cubic. Aquifer losses, including aquifer losses without partial penetrating, and the aquifer losses due to partial penetration. And the other factor is called well loss. Well loss at near the borehole, and well loss due to flow through the gravel pack in the case of the gravel well. And the well losses due to flow through the filter hole into the well. Lastly, well loss due to the fraction losses by flow inside the screen and rising main. Total well loss mathematically equal PQ plus CQ square. Well losses, they are main reason of well losses, including partial penetrating of the aquifer, for example, partial length of screen into the well, poor quality of gravel pack, and poor washing that does not work for the mud cake to come out from inside the well as well as the back washing. Lastly, pumping the aquifer in large quantity that exceeds the recharge. That means discharge more than the recharge. Aquifer losses from these methods, the hydraulic efficiency of the well can be estimated when applied the following methods. One of these methods, the angle methods, and the second methods called the length of the water column methods. For this example, discuss the aquifer losses in the first quantity of aquifer and second, third, and fourth. The, the minimum quantity is more than 9,000, and the maximum quantity 13, more than 13,000 cubic meter per day. The first methods plotted the total drawdown or BQ aquifer losses against vertical against the quantity of pumping well for this diagram, and second pumping shown in this diagram. After that, measuring the angle between horizontal and the line for BQ in the first step equal 10 degree, and the angle of CQ square CQ CQ square well losses equal 24 degree. Second step also measures the angle of BQ equal 10 degree and aquifer and well losses equal 25 degree. After that, calculate the well efficiency for the all steps or 4 steps drawdown test. BQ equal 8 degree, and the well losses equal 22 angle. The total drawdown equal 30 angle. 22 plus 80. Well efficiency equal 8 or BQ divided to total drawdown. 8 angle divided to 30 angle divided in 100 equal 26.7% well efficiency. This is the methods, average oil pumping stage. Second methods, the length of water column methods. Water column for the aquifer losses equal 1.3 meter, and the well losses equal 3.8, total equal 5.1. After that, how to calculate the well efficiency? Divided 1.3 aquifer losses to total loss 5.1 divided in 100 equal 25.5%. Another methods for estimating the well efficiency called slope methods. Slope methods including straight line slope. From these methods, the following hydraulic coefficient are determined. One of these specific drawdown, A, and coefficient of aquifer loss, capital B. Lastly, coefficient of well loss, capital C. These methods clear in this diagram, plotting total drawdown and well losses and aquifer losses vertically against the quantity of discharge of well in millimetric paper. The slope of total well loss here at point A, and the value of A, B, coefficient of aquifer loss, and the C value here in the well loss. After that, calculate the well efficiency depending on this equation. The well efficiency equal 25%. Another methods for slope methods, how to estimate the slope from any point of the straight line, any point. Selected this point at the total well loss equal 2.1 meter, and well losses equal 1.6 meter, and the aquifer loss equal 0.54 meters. B BQ, CQ square, and total losses, drawdown. After that, calculate well efficiency depending on the value of A, B, C. Well efficiency equal 25.6%. Slope methods depending on the angle of BQ and CQ square and total loss. BQ equal 8 degree and the well loss equal 24 degree. Total loss will equal 32 degree. 32 degree. After that, calculate the well efficiency equal 25%. Now, how to control the well efficiency. After to control well efficiency, there are no decline in the occur in the well inside the well because the water level in the aquifer overlap the water level inside the well. There are no difference between two levels. How to estimate of the optimum amount of discharge? First methods, discharge versus total drawdown. Drawdown, drop vertically on the millimetric paper against the total discharge, vertically on log paper, and the paper used semi-log paper. In the cross line in this point, optimum amount of discharge equal 5,400 cubic meter per day. Second methods. The first method. Second methods. Plotting discharge versus aquifer loss. Aquifer loss vertically and discharge horizontally on the log paper. Also in this point, the amount of optimum amount of discharge equal 5,400 cubic meter per day. Third methods, plotting discharge versus well loss vertical and Q horizontal on semi-log paper. In this point, also the amount of discharge equal first and second method previously. Control of well losses, estimate optimum aquifer loss. How to optimum aquifer loss? First methods, plotting the data of discharge against total drawdown vertical on the semi-log, on the log, and the Q data plotting horizontal on millimetric paper. The paper used semi-log paper. This in cross line in vertical total drawdown, calculate optimum aquifer discharge equal 0.5 meter. This is the first method. Second methods, plotting discharge versus aquifer losses. Aquifer losses vertical on semi-log on log paper on log scale, and the quantity plotting horizontal paper, semi-log paper. In this cross point, estimate the optimum aquifer loss equal 0.54 meter. Third, methods total drawdown against aquifer loss. Also, the value, the same value of the uh, optimum aquifer loss. Also, fourthly, aquifer losses versus well losses. Aquifer losses plotted vertical on log scale, and well losses plotting horizontal on the millimetric scale. Paper, semi-log paper, in E, optimum aquifer loss equal 0.45 millimeter. Also, fifth methods, total drawdown versus well loss, plotting on the semi-log paper, optimum aquifer loss, the same value. Lastly, how to estimate the optimum discharge depending mainly on the well loss. In this method, plotting the aquifer, plotting the well losses vertically against the of the quantity, plotting on the millimetric paper. At this point, optimum discharge equal 5,400 cubic meter per day. New methods discuss the control the well efficiency after plotting the data of well and aquifer data in this diagram. Total well loss plotting and well losses. Lastly, aquifer loss. In point A, cross the total well loss and aquifer loss crossed in point A. In point A, aquifer loss equal 0.55 meter, and Q, optimum Q, equal 5,400 cubic meter per day. And this point, the well losses equal zero. That means water level in aquifer equal the value of water level inside the well, overlapping between two water level. Turbulent well loss equal 4.4 millimeter, and aquifer losses B1Q equal 0.5 meter, and linear well loss B2Q equal 0.76 meter. Laminar losses BQ equal B1Q plus B2Q equal 1.3. Lastly, aquifer efficiency equal 23%. Also, by the measure the angle laminar loss BQ equal 10, and turbulent loss, well loss equal angle equal 33 CQ square. Total well loss equal 44. After that, well efficiency equal 23.3%. Second methods angle. Optimum well efficiency in the how to calculate the optimum well efficiency depending on the cross between aquifer loss and total loss in point A. In point A, BQ equal 0.5 and Q optimum Q 5,400 cubic meter per day. Well efficiency equal 0.5 divided to 0.5 plus zero means well efficiency equal zero in this point. This point, well efficiency equal zero, well efficiency. After that, the well efficiency equal 100%. This is the new methods useful for controlling the management of water resources or groundwater resources. Optimum discharge equal 5,400 cubic meter per day. After discharge aquifer quantity 6,500 cubic meter in point B and C. That means the aquifer loss BQ equal 0.6 and CQ equal twice the aquifer loss. Total loss equal 1.3. They are the same value between BQ and CQ square. After that, the well efficiency equal 50%. That means, or this phenomena refer to well efficiency decrease at the rate of point A. Point A, well efficiency decline step by step in this direction. Also, the well efficiency decrease at the left of point A. That means point A is the optimum well efficiency. Conclusion: pumping well from different discharge at the peak point A is the optimum discharge. In this point A, well efficiency equal 100%. Decline in the Q, well efficiency less than 100%, but the water flow in the aquifer laminar is the laminar flow. In the right side of point A, to flow laminar and turbulent flow. Also, the well efficiency less than 100%. Lastly, I need to discuss some issues for another pumping test. For example, recovery test. They are one methods in the world to calculate recovery test depending on straight line data of recovery test plotting on semi-log. But in the new methods must be plotting the data of the field on the millimeter on the log paper. The data of the field. There's that matching between the size type curve. In choosing point equal S dash equal 10 and T over T dash equal 1. After that, calculate the transmissivity, hydraulic conductivity, and transmissivity. Another issue I need to discuss in this presentation: drawdown or recovery test. This data must be plotting in the same paper. Also, where it separate between drawdown data and recovery data. But pumping the one well must be compared between DD to drawdown data plotting in this side against recovery data crossed in this point. In this point, calculate delta S. Is the new methods previously, and also previously I need to discuss water quality. The world studies the Piper diagram, but in my book, including presentation, divided some four new diagram discuss water quality. الحاجة بنقى diagrams. This is one of the diagram like paper show the some or five zone 1, zone 2, zone 3, zone 4, and zone 5 also in this slide. Five zones or 10 different type of water discussed in this table. Water table divided into five type of water. Second diagram of الحاج النقا for me. Also this shape discuss the four type of water: zone 1, zone 3, 4, and 3. Also, they are diagram discuss the different type of water, ground or surface. Lastly, diagram for me also discuss the four type of water. Lastly, thank you for the King Saud University and the all organize the conference of water resources and arid environment. Thank you.